Hello class. Today in this video I will do a recording on this exercise io3 underscore 2 on page 2-43. You should be able to get the same exercise from the handout. To start, we double click on this icon, Visual Studio icon. I'll do a new project called Chapter 2. Select Win32 console application. Click OK. The result will come out. Click Next. Check Empty Project and uncheck STL. Press Finish. You should see the Chapter 2 project created here in your Solution Explorer. If you do not see the Solution Explorer, go to View and click on Solution Explorer. Next, right-click on the source. Over the spirit, press Ctrl-Shift-A to add your project. The program file is io3_2.c. Make sure you have the .c extension. Click Add and the editor will be created. First thing you do, include standard I/O. Every program must have an entry point, which is called min. Next, we put in the skeleton. First, declaration, then initialization, then calculation, and finally output. So now, if you refer to your output, we will first create this output. Okay. So we have a few printf statements. This will be enter the value of resistance 1. Okay. We are not sure about this. Look like a decimal. We put a D first. Okay. Next we copy change this to 2 and change this to 3. Next we will print the three resistors are look, it's a floating point value, so you put percentage %F ohm and percentage %F ohm. Okay. Printf statement connected in series. The equivalent resistance resistance is equals to a floating value. Oh, don't forget the semicolon. And we have another printf statement. Okay, I think I just copy this. And this will be parallel. Okay. So, alright. So we press Ctrl F5. Okay, you notice everything is messed up. So the reason is that we have missed out the carriage return. So now add in the carriage return. Yeah, yeah, yeah. Don't forget there's one extra carriage return here. If you run this time, there's a missing semicolon. Okay. Notice that all the values are 0 because we have not initialized it. So next before you can do initialization, we need to declare the values. Since we have R1, R2, and 3 resistors. And because we need to input the value, we need to have 3 initialized by keying in the value. We use the scanf function. Scanf %d. We have 3 scanf value. And the scanf value have ampersand R1. Okay. R2, and we have R3. Okay. Alright, so if we run this, we should have okay, in order to print out the value, we need to move this thing up to here. So enter this value, then we take away this. Okay, because of the scanf function, and we do not need this anymore. Okay, if you run this function now, okay, we ask you to enter the value. Okay, output is still 0, but the input is the scanf part is done. Okay, next we'll do the calculation. Calculation is given. So we have the series resistance equals to R1 plus R2 plus io3. Okay, but notice that RS indicate an error because we have not declared it. So to do that, we need to put a float here for series and the parallel resistance. So this is resolved. Okay. So we can run that again. The series resistance is still 0. Okay, there's a problem because there's a conversion from integer to float. Alright, so that's why it's not working properly. To do that, we will change the resistance to float. Okay, so we have to change this to F. Now the R1, R2 is all float, we have to change this instead of all the D to F. And this is the output value. And we have to change, this is the input value and this output value. So we can just put R1, R3. Okay, let's try it again. 10, 20 and 30. Okay, this is okay. This is still 0 because we never put in the series resistance here. Then 20 and 30. Yep, we got a series resistance. Now we'll do the parallel resistance. 1 over three. Okay, since it's over the whole thing, we need to have a big bracket over the whole thing. Otherwise, it will be only 1 over this value. So since it's over the whole value, we need to have a big bracket over it. Okay, we need to change the parallel resistance over here. Let's try and compile this. 10, 20, and 30. Okay, let's check the answer itself. 10, 20, 30. Okay, everything is in order. So that concludes my exercise.